Hi, question number 9 taken from June 2014, A-Level Maths HSC Paper 3. The population of a country at time t years is n millions. At any time, n is assumed to increase at a rate proportional to the product of n and 1 minus 0.01 n. When t is equal to 0, n is equal to 20 and dn over dt is equal to 0.32. Treating n and t as continuous variables, show that they satisfy the differential equation dn over dt is equal to 0.02n times in brackets 1 minus 0.01n. Solve the differential equation, obtaining an expression for an expression for t in terms of n, and also find the time at which the population will be double its value at time t is equal to 0. Okay, for the first part, let us move on. Now we are told that n increase at a proportional rate to the product of n times n minus 1 minus n. So dn, therefore, dn with respect to time over dt, okay, is directly proportional to the rate, okay, to n times 1 minus 0.01n. That means we're going to have to put a constant k there. We are told that t is equal to 0, n is equal to 20, and dn over dt is equal to 0.32. So we just need to substitute these values in here. dn over dt is 0.32, k times n, and n is 20, okay, times 1 minus 0.01 times 20 in brackets. So k is going to be 0.32 divided by 20 times 1 minus what is 0.01 times 20, that's going to give us 0.2, and alright, so we got 0.2 here, and therefore that's going to be then 1 minus the answer 0.8, and you got times 20. Alright, and then you take 0.32 divided by the answer 0.02. So k is going to be equal to 0.02. Therefore, dn over dt has been shown to be equal to 0.02 n into n minus 0.01 n. So here we are for the first part. Now for the second part, we need to solve the differential equation. Okay, so to solve the differential equation, we're going to separate the variables dn and n. All the n can come on this side, so I can say dn over dt here is equal to 0.02n into 1 minus 0.01 n. So therefore the integral of 1 over n into 1 minus 0.01 n with respect to n can equal to 0.02 dt. Right, now from here, this looks like a partial fraction to me. Therefore I can say 1 is equal to okay, over n into 1 minus 0.01 n. Okay, that's going to be a over n plus b over 1 minus 0.01 n. Now what does this leads to? It leads to the n and n can go out. I got 1 is equal to a times 1 minus 0.01 n. Then I got plus b times n. So let n is equal to 0. What is going to happen? This is going to be 0. This is going to be 0. So we got a is equal to 1. Therefore a is going to be equal to 1. Let n is equal to, here, if you take 1 divided by 0.01 is going to get 100. So we can say n is equal to 100, and therefore we're going to get b is equal to 1 divided by 100, which is 0.01. Right, so clearly, so we are good to go now. You can still do that. I'm doing it mentally here, so that's fine. what is our integral? So the integral of this left hand side is going to be then integral of a, which is 1 over n, alright, plus the integral of the second part b is going to be 0.01 divided by 1 minus 0.01 n with respect to n. So again, alright, so let's do this integral of 1 over n. That's going to be ln n. We got a minus here, minus 0.01 divided by 0.01, which is 1, and then there's a minus. Okay, so that's going to be ln 1 minus 0.01 n. Alright, so that's the part of it, is equal to the integral of 0.02. That's going to be 0.02 t plus our constant a. We need to substitute the values. We are told that t is equal to 0, okay, when n is equal to 20 and dn over dt is equal to 0.32. So we can replace all those values in here. So what is then going to happen is ln 20, because n is 20, minus ln 1 minus 0.01 times 20, 1 minus brackets 0.01 times 20, it's going to give us 0.8. So that's ln 0.8, okay, and is equal to t is 0, so that's going to be a. So 20 divided by 0.8, okay, so we've got then 20 divided by the answer is going to give us 25, meaning that a is going to equal to ln 25. We divide because there's a subtraction here. This is the property of logarithms. Now, so we can rewrite the equation ln n minus ln 1 minus 0.01 n, oh sorry about that, is equal to 0.02 t plus ln 25. We're going to rearrange this and express t in terms of n. So that can be divided. So I got then ln, this can come on this side. So ln, let us say ln n minus ln 1 minus 0.01 n minus ln 25 is equal to 0.02 t. Right, so let's do the division. So we're gonna get ln 1 n over divided by 1 minus 0.01 n. Okay, if we divide by 25 here, we can divide by 25 as well. Okay, then we are going to get t. The 0.2 can come here, and that's going to be a division as well. So 1 over 0.02, 1 divided by 0.02 is going to give us 50. So I got then 50, and 1 divided by 25 is, so 1 over 25 is going to give us 0.04. So maybe I can say times ln 0.04 divided by 1 minus 0.01 n. So this would be our integral for t. Therefore this is t. Alright, and good. So that's t expressed in terms of n. For the last part of the question, we need to find the time at which the population will be double its value at t is equal to 0. Double its value. So for the third part, and t is going to double its value. What is the value of the population n is going to double its value. What is the population? The population initially was 20. Double that, therefore the new value of n is going to be 40. So we're going to replace 40 in here. Alright, so then I've got t is equal to 50 times ln. So this is basically, oh sorry, there should be n here because there's n. Alright, so 0.04 times 40 divided by 1 minus 0.01 times 40, and then we're going to do all of that from our calculator here. Alright, so 0.04 times 40 is going to give us 1.6. Okay, and then we got 1 minus 0.01 times 40, 0.6, so 1.6 divided by the answer is going to give us this much. ln of that is going to give us 0.98, so that's going to be t is equal to 50 times all of that here, 0.98082 and so on. So you multiply by 50 and it's going to give you 49. So t is going to be 49.0, and here we are for this question. Take care.